Hi, this is Brandon Baines in the Math Department at Lipscomb University, here to talk with you today about empirical and theoretical probabilities. In this app, you'll learn how to calculate both empirical and theoretical probabilities. When dealing with probability questions, we have quite a few terms that we'll need to define. The first of those is an experiment. It's a controlled activity that yields a set of results. Controlled in this case usually refers to controlling the activity in such a way that when we repeat the activity, we get the same possible outcomes and we're not affecting the possibility of those outcomes. So you might think back to if we flip a coin that's considered fair, that's a controlled activity. The results from an experiment are called outcomes, and the collection of all the outcomes from a collection of outcomes from an experiment is called an event. An event could be a single outcome. I should point that out. Should be a single outcome could be considered an event all on its own, or we could group several outcomes together to make an event. For example, if we roll a six-sided die and we observe the number rolled, the experiment in this case would be rolling the die. The outcomes would be the values 1, 2, 3, 4, 5, and 6. And the possible event, one possible event, could be the event of rolling an even number. There are two types of probabilities that we'll discuss. The first of those is empirical or observed probability. I like to say observed probability for empirical probability. For some event, we call it event A. Notice that P parentheses A is the notation that we'll use here. That is representing the probability of event A. And it is simply the ratio of observed occurrences of event A to the number of times the experiment was conducted. Take, for example, if we flip a coin 10 times and we observe heads, heads, tails, heads, tails, tails, heads, 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 tails, we could find the probability of flipping tails, and we would find that by counting how many tails we flipped out of our 10 flips. And so if we look back at that, it looks like we flipped 4 tails, and we flipped the coin 10 times. So that is 4 out of the 10, or 0.4, if you write the probability as a decimal. And that would be the empirical or observed probability of flipping tails. Theoretical probability is the notation is the same, so we still use this P parentheses A to represent the probability of event A. And it is also defined very, very similarly, except with theoretical probability, we don't have any observed occurrences. We're simply talking about how could they occur. Okay, so our ratio then is the ratio of the possible ways event A can occur to the number of possible outcomes for the experiment. So we take, for example, the theoretical probability of rolling, a 3 or a 5 on a six-sided die. Okay, well, if we roll a die, six-sided die, a 3 or a 5, that's two different outcomes. So there's two possible outcomes for our event of rolling a 3 or a 5. And there are 6 possible outcomes, because when we roll a die, we could get any of the 6 numbers. So this theoretical probability is 2 out of 6, or reduced to 1/3. There's some very important properties of probabilities. First, all probabilities must be values from 0 to 1. If the probability is 0, then that event can't occur. If the probability is 1, then the event must occur. And if we take all the possible outcomes of an experiment and we sum those up, those must sum to equal 1. Let's take a look and see if we can determine whether we're looking at an empirical or theoretical probability. First, consider the probability of selecting a heart from a standard 52 card deck of cards is 13 out of 52, or reduced to 1/4. Second, we'll consider 100 people were surveyed about their TV viewing habits. Of the 100 people, 38 of them selected HBO as their favorite channel. And the probability of HBO being favorite was found to be 38 out of 100. And again, we want to know, is this theoretical or empirical probability? Well, the first example there is theoretical probability because the calculation is considering the possible ways to draw a heart from the standard 52 card deck of cards. And we have no observed results of the experiment. We haven't actually drawn cards here. The second example is empirical probability, or again, I like to say observed probability, because we are indeed observing results from the experiment, and that calculation is based on those observed occurrences. A really important idea is that every probability that we calculate will actually tell us two probabilities. Considering this big idea that we said that all the outcomes, all the probabilities of the outcomes must sum to equal 1, this will allow us to say things like, if the probability of event A is 0.3, then we have all these other probabilities that aren't A, they're not event A, and the probability of those occurring, those things that are not A, would have to be 0.7, since all of those outcomes must sum to equal 1. And so this gives us the following formula here. The probability of event A is given by 1 minus the probability that A does not occur. Consider the experiment of selecting a single card from a 52 card deck of cards. We're going to find the theoretical probability of the following: selecting a 7, not selecting a 7, selecting a jack, queen, king, or ace, selecting a heart and a spade, selecting a card greater than 5 and less than 8, and finally selecting a heart, diamond, club, or spade. In part A, there are 4 7s in a deck of cards, so the probability of selecting a 7 is 4 out of 52, or reduced to 1/13. In part B, since we already know that the probability of selecting a 7 is 1/13, we can say that the probability of not selecting a 7 is 1 minus the probability of selecting a 7, using that big idea we summarized a few slides back. And that results in 1 minus a 13th, or 12/13. In part C, there are 4 jacks, 4 queens, 4 kings, 4 aces when we look at a deck of cards. So there are 16 ways that the event can occur. And so that probability of selecting one of those is 16 out of 52, or 4/13. Part D, there are 0 cards that are both hearts and spades. So the probability of drawing a heart and a spade on a single draw is 0. The event cannot occur. In part E, cards greater than 5 and less than 8 are the cards that are 6s and 7s. There are 4 of each of those, the 4 different suits. And so there are 8 possible outcomes for this event. So the probability of a number greater than 5 and less than 8 is 8 out of 52, or 2/13. Finally, on part F, all of the 52 cards are either a heart, diamond, club, or spade. And so this probability is 1, because it must occur. When you draw from a standard 52 card deck of cards, you must draw one of those cards.